Hey everyone. For this stream, my goal is to work a little bit on the Code Crafters Let's Build Redis challenge, course. Essentially, in this course, I'll give you kind of guidelines and instructions and steps on how to do certain things without exactly telling you how to do it. So we're going to walk through that. Go step by step and slowly put together Redis. Should be fun. Okay. So I've already got a repository set up. Right now I'm on step 2, or, well, the respond to ping task. In this stage, you'll implement support for the ping command. Redis clients communicate with Redis servers by sending commands. For each command, a Redis server sends a response back to the client. Commands and responses are both encoded using the Redis protocol. Ping is one of the simplest Redis commands. It's used to check whether a Redis server is healthy. The response for the ping command is pong, registered nurse. This is the string pong encoded using the Redis protocol. In this stage, we'll cut corners by ignoring the client input and hard coding plus pong, registered nurse, as a response. We'll learn to parse client input in the later stages. Okay. Very simple. Notes, you can ignore the data that the tester sends you for the stage. We'll get to parsing client input in later stages. Now you can just hardcode pong as the response. My bad, it's a little bit late. You can also ignore handling multiple clients and handling multiple ping commands in this stage. We'll get to that in later stages. In the exact bytes of your program will receive won't just be ping. You'll receive something like *1 rn $4 rn ping rn, which is the Redis protocol encoding of the ping command. We'll learn more about this in later stages. Okay, that sounds good. We're not going to look at any code examples or anything like that. The goal is to not use that during any portion. I'm going to work on just straight up reading documentation. If I have something that I'm not quite sure how to do and go, I'll just Google it. But either way, the goal is to not just straight up look up the answer. So, overall, obviously, we're in the beginning of this project, so nothing crazy at all. So, this is what we have so far. We have our listener. Sure, it returns like a connection or something. Yeah, exactly. Okay. So con.write. Does it not like me doing that? Is con like a reserved word? It is. I'll just say C. Usually Go likes it when the Go method of doing things is just have very short and straightforward names, or like short names that are like shortened versions of the variables. The name, Jesus Christ. C.write. Why is that not working? Accept waits for and returns the next connection to the listener. Oh, for Christ's sake. Okay, so I can do that. Screw everything I said. I want it to be con. Con.write. And, we're just gonna keep it very simple. We're just going to return the byte array and then plus pong /r/n. I believe that was it. I think I need to just capitalize and that's it. Yep. Perfect. So let's go and submit that. Git add dot git commit -m hard coded pong git push. Now it's automatically going to go ahead and test for us, see if it works. Fantastic. Test passed. Very easy. If I didn't get that, I'd be very disappointed. Okay. Passed. Awesome. Let's go ahead and move on to the next step. No, Markdown support, that's kind of cool. How to pass this stage. In this stage, you'll implement your own... wait, no, I just need to go to the next one. Respond to multiple pings. In this stage, you'll respond to multiple ping commands sent by the same connection. A Redis server starts to listen for the next command as soon as it's done responding to the previous one. This allows Redis clients to send multiple commands using the same connection. This is going to get interesting, mostly because I have not done something like this yet, even though I'm sure it's going to be pretty fucking simple because we're still in the beginning of this. Yeah, and it's marked as easy. Tester will execute your program like this. It'll then send multiple ping commands using the same connection. For example, it might send echo ping /n ping. Okay. One for each command sent. You'll need to run a loop that reads input from a connection and sends back a response. So just like the previous stage, you can hardcode the response for the stage. We'll get to the parseling client. The ping commands will be sent using the same connection. We'll get to handling multiple connections later stages. Okay. So Joyd. So I guess I'm just splitting it on the /n. Then send multiple ping commands using the same connection for, yeah, okay, I think so. Let's try that out. Con.read reads data from the connection. Read can be made to time out and return error after a fixed time limit. See set deadline and set read deadline. Okay. Data equals make. I feel like this is not the right way to go about it because I Jesus Christ. So I'm just gonna make a byte array of size 1024 and read it into that. The reason why I say I don't think it's the right way is because if you are working on accepting something that's greater than 1024 bytes, then it's not gonna work, or at least it'll cut off early. But you know, that's a problem for future byte. For ID, not gonna need that. Val in range. That's not how you do that. Bytes dot split data byte /n. And then we just write it. Honestly, yeah, I'm not really using that either right now, just because no new variables. Okay, there we go. So okay. I didn't know I could do that. That's cool. If you're not going to actually use any of those values, you can just say for range. Okay, that makes sense. My breathing's fucked. Git add dot attempting multiple ping. I don't know why I'm typing that. Just git add git commit dash m attempting multiple ping responses. Git push. I'm not sure. I'm not sure if this is gonna work. No, it didn't work. Found extra data. Oh shit. Because there's an extra one at the end. So IDX val and that. But I don't need that, so I can just do that. If val string val equals that break. Git add dot git commit dash. Kind of wish I could use lazy git with this. I like lazy git a lot. It's a nice interface, nice TUI. But I don't think I would get the instant response from this, which is a very nice thing to have. Git commit dash m fixed too many responses. Git push. Let's see if that works. No? Found extra data. Jesus Christ, I got a cough apparently. So go ahead and start debugging, because for some reason we are adding an extra one here. I'm not sure why. So now slash n %q, so that way we know exactly what it is. And do another one there. And also, let's go ahead and just completely write out our data. Data received. I did not pass in the data, but that's fine. Now, really, it's really annoying to do this. Let me see. Test will execute your program built in. Whatever. For right now, whatever. Git add dot git commit m debug messages. Git push. Shit. You know, it would be nice if we saw how many characters we actually did. So, if anyone doesn't know, for some reason, essentially I initialized a byte array with 1024 characters. It's not just empty. I believe they're kind of null bytes. Either way, it's essentially something that's just taking up the space. And it's processing that extra space, which is obviously not what we want. Func handle error. Nah, I have that backwards. No, I don't. I had that right. If error does not equal nil, log not fatal error. We'll go ahead and handle the error. No biggie. And here, let's go from the beginning to end. Okay, that should fix our issue. Here's hoping. Actually muted my mic that time, so hopefully that won't be heard. So git add dot git commit dash m, no longer processing null bytes. Git push. Fuck. Found extra dick. /r/ and so we have one here. We have one here. Maybe what I can do is say if strings dot contains string val ping, then that probably would have been a lot easier. Let's get rid of all that shit. We don't need that. This should definitely fucking fix it. Git add dot git commit dash m. This should do it. Git push. Received, no content received. So, I kind of want to go back to the previous one and see if I can look a little bit more into this. I want to understand more about this. I might go back in and add this, but I'm only going to add up to n. Git add dot git commit dash m more debugging. Git push. Git push. Data received. Received the pump. Client 1. Expected start of a new. Are they different connections? I feel like that's what it is. It'll then send multiple ping commands using the same connection, for example. You need to run a loop that reads input from a connection that's sent. I mean, sure. If I just put this shit in here and just say constantly accept a new request, I feel like I obviously must have misunderstood it. Git commit dash m handling multiple requests. Git push. Motherfucker. I'm gonna set debug to true in the YAML because I'm having a hard time understanding what the fuck is going on. Git dot git commit debug. No true. This is making me feel stupid. Very, very stupid. Let's see how verbose this is. That was not very verbose at all. Client 1 sent bytes. Client 1 receive bytes. Client 1 receive ISP simple string. Okay, receive on sent. Okay. Maybe I have my loop in the wrong area. I think that's what I have. I think I need to start the loop a little bit in a slightly different place. above my data. Right there. I think that's what it wants, because it'll read the data, process it, and yeah, I think that's actually what it wants. That wasn't very verbose. I'm assuming it'll probably get much more verbose as time goes on. Get add dot get moved get push. 50th time is the charm. Finally. Okay. That was embarrassing how long that took. I feel like we can try one more. Start this stream a little bit late, so it's not gonna be as long. Let's look at the next one. Let's mark it as complete. Let's check out these. I don't get to see what the... I already saw the training badge. Handle concurrent clients. In this stage, you'll add support for multiple concurrent clients. In addition to handling multiple commands for the same client, Redis servers are also designed to handle multiple clients at once. To implement this, you'll either need to use threads, or if you're feeling adventurous, an events loop like the official Redis implementation does. Your tester will execute like this. Emergency line that will then send 2 ping commands concurrently. Your tester will expect to receive 2 pong/r/n responses. Since the tester client only sends the ping commands at the moment, it's okay to ignore what the client sends in a hard-coded response. We'll get to parsing in the future. Let's check out this event loop a little bit. And that's just a fucking wiki entry. Okay. Maybe we'll get more into that in the future. I'm not really too worried about that. Okay. So, I actually haven't done concurrency in Go yet. I hear it's very simple. I think it's really just as simple as something like Go Funk. Is that right at all? Golang concurrency. Once you have Go installed, learn how to organize and work. Packaging reference to further explore Go's concurrency model. Nope, not what we're looking for. Thank you. I can't remember what the hell the name of it is. Of the name of their, like, Go routines. Holy shit. Thank you. Golang Go routines. I don't know why the hell I didn't have dark mode enabled on the other one. Funk says that. Funk main. Say go. Say hello. Okay. Really? That's it? That's easy. I knew. I had a feeling it was gonna be easy. Funk handle connection. I'm sure we're gonna have some parameters here in just a minute, but we'll get to that. Don't need that. Go handle connection. I believe that's a net.listener. And then you call that L. Picking this up. Red vs. Blue by Bakey Nap. I like it. I honestly think that's it. Git add dot git commit dash m concurrency. God damn it. There we go. Git push. Git I can't. Will it work? Nope. It will not. Did I fuck that up? Go routine is a lightweight thread managed by the Go routine. Whatever. Starts a new Go routine running F. Evaluations of F. And the execution of F happens in the new routine. Go routines run in the same address space, so access to shared memory must be synchronized. The sync package provides useful primitives. I don't really need that. That's not what I'm looking for. I don't think so. Did I do that in the wrong area? So one thing I really need to do is I actually need to defer on die close. So that's something I wanted to do. I feel like if I put this here, it's not gonna work right. Because it's not concurrently handling connections. I know this isn't gonna work, but let's try it. Git commit dash m. This won't work. Git push. I just want to try it. I'm sorry, what? Okay. So why is it calling the function? It seems like it's not calling the function at all, which is weird. The hell is the issue? Well, we realize that that's actually not what I want. So I'm gonna do that. But some bytes plus failed. Okay. Func save. Name. Golang, go not executing function. Why is it not being called? Runtime. Maybe? You're just experiencing a timing issue because you're not coordinating your Go routines. A common way to handle this is with a wait guard. The other option I see from time to time using channels and a blocking select. A wait guard implementation. Wait. looks something like that. That was nothing. While the channel option, not actually interesting or useful in this example, is something more like nothing like that. You're not allowing the go routine to run before main exits. There's no guarantee that the first go routine can run. Wait group. What? Go routine exits the process. Interesting. I feel like there's gotta be a different way. I've seen different ways for this. For TCP connections. Golang handle multiple TCP connections. Jesus Christ, can I fucking get... Okay, well we have our handle connection, that's fine. That's how they do that. Anyways, not the point. Port arguments, net.listen. Defer, close. Okay, so it just does... Huh. Okay. That makes sense. I feel like I definitely should have figured that out, but whatever. Defer L.close for sure. That's good. Dot hit commit -m concurrency, but for real. Hey chatter. Good time coming in here. How you doing? Git push. Oh, get the fuck out of here. Git dot git commit. Removed unused references. Git push. There we go. We have very simple concurrency. Very, very simple concurrency. Hallelujah. We did not look at anything for that at all. Nope. Why would you even say that? It's not what you did. That stage is complete. Well, viewer that hopped in here, I got bad news for you. I might be about to head off early. Well, I say early, it's 12:20, it's kind of fucking late. But, you know, thank you for joining. Let me check out this last one. We'll just look at it. We're not going to start it. We're not going to do it. We're not going to do any of that. But we will see what the next task is, and we know where we're going to pick up next time. Should be an interesting... Should be very interesting. Your task. In this stage, you'll add support for the echo command. Echo is a command like ping that's used for testing and debugging. It accepts a single argument and returns it back as a RESP bulk string. Redis CLI ping, the command you implement in the previous stage. Pong echo hey, the command you'll implement in the stage hey. Tester will execute your program like this. The tester will expect to receive $3/r/n hey registered nurse. As a response, that's the string hey encoded as a RESP bulk string. Probably look more into that documentation next time. I'm pretty tired. We suggest that you implement a proper REST protocol parser in this stage. It'll come in handy in later stages. Redis command names are case insensitive, so echo, echo, echo are all valid commands. The tester will send a random string Jesus Christ as an argument to the echo command, so you won't be able to hardcode the responses to pass this stage. The exact bytes your program will receive won't be just echo hey, you'll receive something like $2 register nurse, $4 register nurse echo, register nurse $3 register nurse hey register nurse. That's echo hey. Interesting. Okay. Array of 2 elements, new line, 4 characters? Yeah, 4 characters. New line. The actual content. How many characters, what it is, and then boom, the ending. It's actually pretty cool. Okay, we're really going to be getting into something a little bit more interesting with the next one. I'm excited for it. Well, thank you to anyone who is watching along, and I hope y'all think about trying something out like this. It seems like a pretty good way to learn. It's a nice guided teaching tool. Because my biggest problem with these, with courses and other programming resources, is that it's very much a step-by-step guide that teach you how to do something. And I mean, like, to be fair, if we go back here, they have code examples for sure, but that's if you want them. So it's very much optional. It's not very opinionated. There are hints, and people say things on their own. I really like this, and people like drop their, I think people are kind of like dropping their own tips that might have helped them, which is really cool. So, you know, this is actually pretty nice. It's not super cheap. It's like $30 a month, which is, you know, it's a lot. If you're not going to use it, or don't use it very often. But I'm actually liking it a lot. So, looking forward to continuing this tomorrow. And I hope everyone has a great day, great night, whenever they're watching this. I will catch y'all later. Peace.